A lot of the problems really may be interconnected, Vale. You have to look at it from a holistic point of view. It encompasses more than natural sciences or physical problem, Vale, but also it gets into the ecological, biological, as well as social pa nga.
Among issues and problems we have are poverty, ecosystem destruction, climate change, and variability.
Much of our attention is placed only after the disasters happen. What we should do really is to take early action years before the hazard strikes, and we should put our attention and our resources into that type of planning.
We need SMT-based transdisciplinary and inclusive approach to coping with possible hazards.
The fragmentation of society needs to be resolved for resilience.
Communication is very, very important. And we should communicate to the people using not just scientific communication means, but through arts, music, understand the mindset of the Filipino people so we can communicate better.
Well, the way to move forward is interoperability.
We have to do a lot of work as a person, as a community, and as an institution to really have resilience as one of the values of the Filipinos. Yung tunay na resilience na towards improvement.
Resilience requires sustainable society inspired by transdisciplinary approach.
To be sustainable, you have to be resilient. To be resilient, you have to be sustainable.
Go natural, go with nature's flow. Non-structural or natural interventions, as well as good planning, is the most sustainable.
Finally, we need to harness and strengthen the Filipino spirit of bayanihan.
Pero dahil kami ay nasa akademiko, pinag-aaralan namin yung mga...
Ano talaga ang kailangan natin not only for ourselves, but for a people as a whole.
Resilience ng mga Pilipino towards the collective effort among communities and the strengthening of
Resilience Live.
Hello everyone, good afternoon, and welcome to the third episode of the Resilience Live webinar. I am Ella and I will be your host for today. The Resilience Live webinar series is brought to you by the UP Resilience Institute and the UP NOAA Center in partnership with the UNESCO International Geoscience Program, or IGCP. Together, the UP NOAA Center and IGCP seeks to explore geoheritage as a tool in developing resilience towards natural hazards. Our partners for this episode also include the UP Phi Delta Alpha Sorority, the UP Society of Geodetic Engineering Majors, and the Association of Filipino Pharmacy Students UPLB, or APS UPLB. Our speaker for today is a coastal engineer and the team lead of the Marine and Coastal Solutions Department at DHI Singapore. He is an expert in wave and hydrodynamic modeling and has also worked previously as a science research specialist at the Storm Surge Component here at the UP NOAA Center. He earned his bachelor's degree in civil engineering here at the University of the Philippines. He also took a master's degree in civil engineering, major in coastal engineering at the University of Tokyo. Our speaker has also conducted and published multiple studies on probabilistic mapping on storm surge in various parts of the Philippines. Here to discuss his presentation on sustainable coastal development, Engineer John Philip Lapides.
Hello. Thanks for the introduction, Janiela.
Thank you, sir.
Magandang hapon po sa lahat. Good afternoon, everyone. I'm happy to see that there's healthy interest in the topic that we'll discuss today, that is sustainable coastal development. Let me just turn off my video. My connection is not the best. And I'll share my screen. Okay. So can everyone see my screen? Hello?
Sir, no.
Okay.
Not yet, sir.
Okay, I'm sharing my screen now.
So
Can
it's
everyone
visible
see it?
now. Yes, sir. It's visible. It's visible.
Okay. Okay, thanks for the confirmation. So today I'll talk about the main topic. Let me just take a few minutes to introduce my organization, DHI. So at DHI, we enable a sustainable future for water. This is our motto. At DHI, we are driven by a strong purpose, and this is to enable a sustainable future for water. For 60 years, we've been committed to advancing and sharing knowledge of water environments. At a glance, here are some numbers from the past year. We are founded in 1964, and we have almost 60 years of experience within the water environments. Today, we have approximately 1,100 engineers across many offices in the world. We've worked in more than 2,000 projects, and we have accumulated 119 million euro annual revenue in 2022. DHI actually is a not-for-profit organization, so all our revenue goes back into research and innovation, which is our main focus. We have industry-trusted physical and digital test facilities. And of course, Mike, this is our main product, the software for water modeling. We have also partnered with a United Nations since 1996, since 2001. Hey, I think I got disconnected. Hello?
Hi, we can hear you now.
Okay, let me just repeat the last slide. Saan po yung huli niyong narinig?
Medyo paputol-putol
Okay,
lang.
let me just
The last
continue.
slide. Thank you.
At DHI, we have a truly global presence. We are founded and headquartered in Denmark, and we have offices in 26 countries across the world. We have clients in more than 115 countries. I am now currently situated in our Singapore office, this one. We don't have a Philippine office yet, but hopefully soon we'll have one. Sustainability is a central part of DHI DNA and purpose. It is clear that our global water ecosystems are under pressure. There's climate change, which drives more extreme weather conditions, global warming, and rising sea levels. At DHI, our strategy focuses on 5 Sustainable Development Goals, or SDGs. These are the ones I'm showing on screen. We have SDG 6, which is clean water and sanitation. This is to ensure availability and sustainable management of water and sanitation for all. SDG 7, affordable and clean energy, to ensure access to affordable, reliable, sustainable, and modern energy for all. We have SDG 9, industry, innovation, and infrastructure, to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. SDG 13, most important one, is climate action, to take urgent action against climate change and its impacts. Today, I'm going to talk about a specific case study. which is about supporting sustainable coastal development in Jakarta Bay. This is a project that DHI did back in 2011, so more than 10 years ago now. When we talk about sustainable coastal development, different words come to mind. There is economic interest, environmental interest, social interest, and many other conflicting interests. And our job is to balance all these things. Clearly, this is a multi-criteria problem. And of course, to solve a multi-criteria problem, we need input from experts in different fields. Today, I'm just gonna focus on a very narrow area. My expertise and experience lies in coastal modeling. So I'm gonna talk about, obviously, how coastal modeling can contribute to sustainable coastal development. Why is this an important topic? Coastal areas around the world are severely stressed due to a myriad of human activities and marine pollution. They are now detrimentally being affected by climate change and sea level rise as well. Here I'm showing you a picture of the shoreline of Jakarta Bay in 2011. And at that time, there were plans to conduct reclamations, shown here in the right figure. As you can see, there are many developments, more than 10, I believe. So in 2011, our company, DHI, was tasked by the Indonesian government to conduct a rapid environmental assessment, or REA, for the reclamations and associated developments planned along the Jakarta Bay. Before commencing the REA project, the Indonesian government had halted all coastal developments in Jakarta Bay until the cumulative effects could be assessed and addressed. So this resulted in delays. A number of major reclamation projects were delayed, including the expansion of their main port. So I chose this topic because this is a familiar story for most of us, I guess, in this meeting. As you all know, or maybe some of you don't know, there are also planned reclamation areas in Manila Bay. So it's a very similar situation, and I thought we can draw some lessons from the Jakarta Bay project. And similarly, the reclamations in Manila Bay have been suspended just this August. So here I'm just showing some snippets from news talking about the suspension of the Manila Bay reclamation projects. Here is a simple flowchart of the work we did for the Jakarta REA. It started with data collection, modeling, and together with our international experience, DHI conducted a rapid environmental assessment. So from the name itself, it's just a rapid assessment. It's a first level assessment, which is meant to guide the subsequent EIA, or Environmental Impact Assessment, and EMMP, or Environmental Management Plan. And lastly, it was also used as input for strategic environmental assessment. So this one is a more focused assessment that relies on the output of the REA. The REA was conducted in 3 months. DHI determined the existing baseline conditions through site visits and available quantify the key strategic issues for the bay. Screening of these issues then helped to prioritize the key physical, chemical, biological, and economic impact vectors for assessment in the REA. And finally, we used a simple coastal model of the bay to identify the critical environmental issues. Here is a methodology used in the REA. First, we established the baseline by reviewing available secondary data and by conducting surveys. Baseline is simply the pre-existing condition before any of the developments. And then we evaluate the impacts due to the reclamation. So for today's discussion, I'm gonna focus on physical, chemical, and biological impacts. Of course, there are other impacts not covered in this discussion. There are traffic impacts, loss of livelihood, social impacts, and many more. When we establish the baseline, we talk about different things. There is the Met Ocean baseline, hydrology, water quality, environmental data, bathymetry, other modeling studies, planning, demography, air quality, EIA, fisheries, among others. The impact assessment can be broadly categorized into two major groups. The first bucket here is the process impacts. This is the short-term impacts, or the impacts during the construction stage, during the reclamation or the dredging activities. This, of course, is mainly influenced by the reclamation method and by the sequencing of works. The process impacts can be most effectively managed by an environmental monitoring and management plan, or an EMMP. The second bucket over here, project impacts, these are the long-term impacts. These are the environmental changes resulting from the final reclamation and any associated dredging. We mitigate project impacts by optimizing the reclamation profile, by changing the shape, changing the dimension, the orientation, so that we can improve the overall environmental impacts. First, I'm going to talk about the process impacts. When we talk about reclamation and dredging, of course, the main effect is that we disturb sediment, and these suspended sediments may directly impact sensitive receptors. Sensitive receptors may include fisheries, fish farms, or even industrial receptors such as intakes, water intakes, or outfalls. Pollutants bound to the suspended sediments may be bioaccumulated in fisheries, and this will affect, of course, supply of food. Broadly, process impacts are broadly overlooked as part of EIA submissions. We usually EIA focus on long-term impacts, but process impacts can actually constitute the largest impact if not appropriately managed. I'm showing here 3 plots of plume impacts. I removed the legends, sorry for that, because these are confidential results, but let me just use the pictures to tell a story. The first one, this is a mean suspended sediment concentration. A darker color red means a higher value, while a green or yellow is a lower value. So you can see here in this simulation, there are 2 reclamation activities, one here and one here. And you can tell from this image where the suspended sediment can travel. This is the extent of the plume. This second one is the exceedance of this threshold. If reclamation is conducted in these 2 areas, this threshold, 5 milligrams per liter, will be exceeded by this percent represented by the color in these areas. And this third picture is the exceedance of 10 milligrams per liter, which is a higher threshold. In this situation, in this particular simulation period, you can see that the suspended sediments are traveling eastward. And therefore, if there are any sensitive receptors here or here, they will be affected by the suspended sediment. And indeed, looking at this map, there is one big fish farm in this area. And there's another one here in the west. In another simulation where we considered westward going flow, we saw that this fish farm was also affected by suspended sediment due to the reclamation and dredging works. Sediment plume impact is dependent on the quality and quantity of fill material, quantity of dredging, bed material properties, dredging, and reclamation process. On the left, I'm showing a possible sediment plume if the fill material has 1% fine material, meaning those very, very small materials. And on the right, this one is representing 4% fine scenario. If there are more fine materials, they can easily get transported. And so the extent of the plume is much larger. So it's also very important to consider the quality and the quantity of the fill material to be used in the reclamation development. Sediment plume control. The sediment plume can be controlled by good construction management techniques, including but not limited to bonding, or it's like building a wall so that you don't allow the sediment to move beyond the development area. You can also employ silt screens, which are effective in areas where the current speed is not that high. And also you can do a spill budget recommendations we gave as part of this study. In general, sediment plume impacts can be managed even in close proximity to sensitive receptors. This is an international best practice for feedback monitoring and management of sediment plume. You can start with a hindcast or a modeling of temporal and spatial extent of sediment plume, and then you conduct real-time measurement of turbidity, dissolved oxygen, and other parameters at the project site. So this is to calibrate and compare with your model. You conduct a quarterly habitat monitoring of sensitive receptors. This may include corals, seagrass, and others. And lastly, you do a daily measurement of sediment spill, and then you compare this against allowable threshold. So it's a cycle that you continue doing throughout the development period. I'll also talk about some project impacts. As I mentioned earlier, they arise primarily from the choice of reclamation profile. These are the long-term impacts. Most important is the change in current speed, because they act as a key determinant in project impacts covering navigation, water levels, morphology, water quality, and flushing. I'm showing a map here of mean current speed. Again, the darker red color means higher current speed, and the lighter green color is an area with lower current speed. The map on the upper left here is the distribution of the current speed before the development. So this is the original baseline coastline. And on the right is the same thing, but including the reclamation. So what we did was we ran a model, same scenario, but we included the developments like this. With these two, you can actually take a difference. So you just subtract this from this, and you get the net impact or the net change due to the reclamation works. And this difference are the maps I'm showing here at the bottom. Yellow means increase in current speed. The blue means decrease in current speed. There is an increase in current speed here in the eastern end. In the middle one is largely a decrease in mean current speed. And again, at the western end, there is an increase in mean current speed. What we can do is we can streamline the shape of the reclamation. We can tweak it a bit. We can change the orientation. We can reduce the area, things like this. And then we can rerun our model to evaluate if our strategy improves the impact. We don't want increase in current speed, because this will promote erosion. And on the other hand, a decrease in current speed may promote sediment accretion. This one is a wave impact. So it's a similar story. Darker red means bigger waves. The lighter colors are the smaller waves. This is the pre-development, and this is the post-development. And at the bottom, this is the net change. Obviously, because of the reclamation, this will provide shielding to the inner coastline, and therefore most of the waves experienced at the inner coastline will be reduced. Exposure of the shoreline to wave activity may have either good or bad consequences. While on the positive side, waves can resuspend deposits that may otherwise accumulate in shallow areas. This will usually result in blockage of drain outlets. Wave exposure is also good for beach quality in areas with high prevailing background suspended sediment concentration, as in Jakarta Bay. On the other hand, wave exposure leads to erosion, where the natural littoral processes are blocked by structures or natural obstructions. From the maps, it is clear that developments will significantly reduce the wave activity in the existing shoreline. And in this area in Jakarta Bay, where we have high sedimentation rate, this is a very negative consequence because it will enhance the accumulation of sedimentation at the mouths of the various rivers, which in the longer term can lead to negative consequences on the discharge capacity unless they can be maintained by dredging. Backwater impact. So this is an important one. Semi-quantitative assessment of the potential risk of backwater has been made to gauge if the reclamation projects as configured are likely to have significant impact on hinterland flooding and if the impact can be mitigated. Backwater impact simply tells us if the inland flooding will be worsened by the reclamation. So this is a problem also in Manila Bay. We have flooding in many different coastal regions. And so naturally, everyone is worried if we continue with those proposed reclamations, will it worsen the hinterland flooding? In this kind of assessment, you will see the colors here in the mouth of the rivers. If it is red, it means that the flooding can be increased. If it is green or a lighter color, the impact is less. Risk of impacting hinterland flood levels as a result of the reclamation, changing the backwater in the various rivers and canals, is a major concern of the authorities and the public. The eastern sector here, you see the red color, has a mean level rise at the discharge point of more than 10 centimeters. This color corresponds to more than 10 centimeters of increase. This is actually equivalent to 40 years of sea level rise. So it might sound little, right? 10 centimeters, but it can have a significant impact. The consequence of this impact on mean level at the discharge points will have greater probability of hinterland flooding and higher area of impact when flooding does occur. In the central region here, the impacts are smaller, but they are still in the order of 5 centimeters. So if 10 cm is equivalent to 40 years of sea level rise, 5 cm is equivalent to 20 years of sea level rise. And so it is still a risk factor. The western portion here is less affected, less than 1 centimeter of impact seen. But again, this is a preliminary assessment. This is a rapid assessment. This just serves to determine where we should focus our subsequent detailed studies. So definitely we should conduct more flooding studies in this area, and lastly, this area in that order of priority. This one is morphology impact. Morphology is changes in the shoreline, the movement of sediments. One of the primary concerns with any reclamation project is the effect of changes in currents and waves on the morphology of the area. Although there is poor coverage of bottom sediment characteristic data available to the REA, a preliminary assessment of the morphological impact of the development has been undertaken to establish the presence of any key areas of concern. This one here on the left is the mean suspended sediment concentration considering a 48-hour storm. And this one is the impact on sedimentation. Red means erosion and blue means sediment accretion. Significant increase in mean SSC over the west and east aquaculture sites were observed. If you recall, I showed you a map of the aquaculture areas here, east and west. We actually saw that the morphological impact affect these two big fishery areas. Mitigation in eastern sector can be achieved by streamlining the reclamation profiles in the western and the eastern end. This one is a flushing impact. In this study, flushing was used as a proxy for water quality modeling. It is not practical within the short time frame of just 3 months to undertake a full quantitative water quality modeling. And so in lieu of a more detailed water quality modeling, we conducted a flushing assessment. Flushing assessment just measures how quickly a pollutant or a how quickly a pollutant can disperse. So, for example, before the development, you can see very poor retention. The red here is in the order of 7 days. So at the center of the bay, you can see retention times generally exceeding 7 days, while the east and west side of the bay are well flushed. The retention times are 2 days. It means if you release some pollutant, they will be dispersed in this period. Post-development, the conditions were seen to deteriorate. In the central region, from 7 days retention time, it increased to about 14 days, so double. The eastern and the western sectors remain relatively well flushed. So there is optimization required in the middle portion where we see the greatest increase. This is just showing a picture of the actual water collected at the site, showing the poor flushing. You can see here is a darker color compared to just a regular mineral water. One way we can improve the flushing is actually if we just take out those gaps. In Indonesia, there is actually a law that says the reclamations should be separated by a gap of 200 to 300 meters. But these narrow gaps are where we see the deteriorated flushing performance. So in conclusion, completion of the REA allowed some of these projects to proceed, and it provided a clear indication of the issues that the others meaning subsequent studies needed to address before KLH. KLH is the Singaporean government, before the Singaporean government would allow them to proceed. Significant land use conflicts and short as well as long-term impacts on the bay could thereby be avoided and will be avoided in the future thanks to the results of the REA. Through its REA, the JHI set new standards for the management of development projects in Jakarta Bay. First time in 2011, during that project, clear and practical and concrete recommendations were provided on how to fix the problems and allow the majority of the proposed reclamations to proceed without causing conflicts on further negative impacts to the environment. The project has also led to additional SEAs in the region, as well as significant interest from several developers in Indonesia. DHI's work through this REA improved the environmental outcomes of coastal developments and built the capacity of local environmental regulators to properly manage the environment. Ultimately, this will improve the environmental condition of the bay, while at the same time improving the quality of life of the bay's residents and allowing for key developments to continue. So this is my last slide. This just compares the same picture I showed you earlier, the 2011 Jakarta Bay coastline, and then the 2023 one. As you can see, some of the developments were allowed to proceed, but most of them were never continued. That's it. This is the end of my presentation, and we can now go to Q&A.
Thank you very much, Engineer Lapidas, for that very interesting and enlightening presentation. I'm sure our audience has learned a lot about the environmental impact assessment of Jakarta Bay. Being in an archipelagic country, I can't help but also think that we can expect more reclamation projects in the future here in our country. And this case is very relevant and very helpful for our audience coming from different sectors, some of which are environmental planners, some are from the LGU sector, some are students that will be future stakeholders and decision makers, and some are fellow researchers. This study of the Jakarta Bay will be very helpful in developing appropriate policies and environmental plans for our country relative to reclamation areas. Having said that, I'm sure you have also piqued the interest of quite a few of our attendees. So coming up is our Q&A session. A few reminders before we start. To our audience, kindly use the Zoom reaction button to raise your hand and wait for the host me to call your name and unmute you before speaking. To our audience who are watching from FB Live and YouTube, you may also comment your questions below. So I open the floor for a Q&A session. To our participants, you may raise your hand in the Zoom reaction below. And you may also chat. Okay, we have our first question from Miss Trixie Del Mento. You may now unmute and ask your question to our speaker.
Hi, Philip. Good afternoon. Thank you so much for your presentation. So, this is I'm sorry for the new question. This is fairly new to me, and so that I really find it interesting. But I think my question is more of when conducting impact assessments such as this. One, I was just wondering if you have ever had any difficulties isolating the effects of the project, and if so, my second question is, in the case of Jakarta, were there other environmental factors that have like similar results or similar effects, which made it a bit difficult for you to determine if they are caused by the project itself or some other phenomenon? Thank you.
For the second question, thanks, Trixie. For the second question, it can be done by modeling, because in the model we can isolate whatever we want to isolate. If we want to look at the impacts of one parcel of reclamation, we can simply change the model, tweak it this way, tweak it like that. And so we can isolate the individual impacts of specific reclamations. The first question, I forgot the first question. Can you repeat again?
I was just wondering if, for example, for this specific project, were there any other factors which are causing the same effects? I mean, like, are there maybe natural phenomenon or similar, but not it may not be related at all, but it's causing the same thing to happen to the project area?
Yeah, there are, and that's why data collection is very important. We have to correctly identify the situation or the conditions before the developments, so that when we evaluate the impacts, we are sure that the impacts that we're evaluating are solely due to the proposed developments and not due to other pre-existing factors. In fact, we saw pre-existing factors when we did this study. When our team did surveying and interviews, so they saw the underlying situation. As I mentioned earlier, the flushing is already poor. There's also flooding issues. There are pollution issues. So these are things that we included in the baseline, so that when we take the difference, the effect of the pre-existing conditions are taken out of the measure of the impact. Does it answer your question, Trixie?
Yes, thank you. So I guess it really underscores the importance of having a good baseline study as well, so that you are able to tell
Yeah.
if... Okay, thank you so much.
Thanks, Trixie.
Thanks, Miss Trixie. We have a second question in our chat box from Sir Paul Rivera. The Jakarta area is sinking just like the northern Manila Bay, where reclamation projects are going on. They began transferring the city to Kalimantan. Could this be the reason why very slow development is going there in Jakarta Bay?
This could be one of the reasons, Mr. Paul Rivera. You're right. And at the same time, during the course of this study, we identified several negative impacts that they have to address before they can continue with the developments. So yes, there are multiple factors, not just limited to the issues discussed in the topic or during this presentation. Probably the sinking of Jakarta Bay, Jakarta area is one of the reasons. Mm.
Mhm. Thank you, Sir Paul. I hope Engineer Lapitas has been able to answer your question. We receive a message as well relevant to what you said earlier, Engineer. We received a question. What are your thoughts on the Manila Bay Reclamation Project?
Sorry, who asked the question?
Sorry, Engineer, the question is anonymous. The question sender is
Okay.
anonymous.
What are my thoughts on the Manila Bay Reclamation Project? So yeah, of course, this is a very interesting question. It's a very important one. My first thought is that we should conduct a study similar to this, a study that looks into the cumulative impacts. Because I think for the proposed developments, they do their own studies independently, meaning one reclamation look at the impact of only this specific reclamation, and so they might falsely conclude that the impacts are minimal. While if all the reclamations are put into place, the cumulative impacts, they add up. So there should be a study looking into all the reclamations present at the same time, or maybe even sequential reclamation work, sequential dredging. We can look into the long-term and short-term impacts as demonstrated in this presentation.
Thank you, thank you.
But without just to add, Janiela, so without the facts, without this kind of studies, it's a bit difficult to conclude whether there really is significant negative impact or even positive impact of the proposed reclamations.
Very enlightening, Engineer. We have a third question from Sir John Kenneth Suarez. You may now unmute, sir, and ask your question.
Hi, kamusta?
Hi, Kenneth.
Anyway, yun. We're doing some similar works ngayong sinabi mo na initial environmental assessment sa mga coastal structures. So in doing so, we're actually doing at least 2 scenarios sa Philippines, yung more on sa one scenario is the northeast monsoon na scenario and the southwest monsoon scenario. So I'm not familiar kasi sa Jakarta na wind regime. So ginagawa rin ba yun sa Jakarta or any other places na ginawa niyo?
So definitely we look at both northeast monsoon, southwest monsoon, and other seasonal variation depending on the location. No? But in the Philippines, of course, typhoon conditions are also very important. And to add, not just the northeast monsoon or southwest monsoon, we should also look into the inter-monsoon period, because these are the periods where we generally have calmer environments, meaning flushing might be poorer because of lower current speeds during these periods.
Yes.
So yes, we do look into different monsoons, typhoons, intermonsoon, different criterias, different periods depending on the actual project site. So thanks, Kenneth, for your question.
Okay, thank you.
Thank you, Sir Kenneth. We have another 2 anonymous questions from 2 anonymous participants. The first one is, can we use the REA for offshore structures? What would be the limitation? And I think this would also be done to the proposed project on offshore windmills.
Definitely, a similar approach can be applied for offshore structures. For offshore windmills, yes, we do similar studies for this kind of structures.
Thank you, sir. The next question from our second anonymous participant is following with Ms.
What would be the
question.
limitations? Sorry, Janiela.
Sorry, sir, you may
I think I
continue.
got disconnected there. Can you hear me
You may
now?
continue, sir. Yes, sir. You may continue.
Okay, so there was another question. What would be the limitation? I think one limitation is the availability of data or the baseline data. This is very important so we can isolate the impact of just the development. Mm. Okay, the next question.
The next question, sir, is following up with Ms. Trixie's question regarding the phenomenons you included on the assessment. How did you verify the model created from the parameters or factors that you have decided to include? What model validation did you utilize to assess the accuracy of your models?
So in this specific project, just because of the nature of it, it was a rapid assessment. There was no calibration or validation performed, but our models are, I can call it pre-calibrated. We were able to demonstrate that these models are able to generally capture trends, hydrodynamics in waves in many different regions in the world. Now, of course, when we conclude to do more site-specific EIAs or more detailed studies, this is the opportunity where we can do model calibration and model validation. This is where we can recommend to conduct on-site measurement, data collection, and this can typically last for a few weeks or even months, depending on the data that we want to measure. And this luxury of time was simply not available during the REA stage. So this will be performed in the subsequent more detailed studies.
We also have a question from another participant here at Zoom from Sir Jericho Mendoza. Is solid waste included in the modeling? And second, does Jakarta Bay Reclamation have cultural heritage impact study?
So the first one, solid waste included, depends on the size of the solid waste. If you're talking about microplastics or small particles, you can look at the flushing impacts, because these small particles generally follow the trends, the currents, the predominant hydrodynamics in the region. Now, if we move into bigger solid waste, this was not included in the modeling, but we have done studies that also look into these kind of questions. There's a particle tracking. We can do bigger trash, not just microplastic. For the second question, does Jakarta Bay Reclamation have cultural? It was highlighted in the REA that there is cultural factors that have to be considered. I am not aware if there was any subsequent, more detailed impact study performed by other groups, but it was highlighted in the REA.
Thank you for clarifying that, Engineer. We also have a question from one of our viewers at YouTube. For the backwater impact model, does it or could it account for the facilities that induce or assist water flow, like NCR's pumping stations?
So once we've highlighted the areas where there is significant negative impact, and once we move on to the more detailed modeling, we can definitely include other features, flood control facilities, drainage, all these things. We can definitely include them in a model. But this kind of modeling will, of course, take more time and require more resources.
Thank you. He also has a follow-up question. What modeling software did you use?
So we use our Mic suite of modeling. This is our in-house software developed by DHI.
Thank you for answering that. And we have another question from Sir Paul C. Rivera. What is the impact of the planned reclamation developments on sedimentation erosion regime, especially during stormy winds?
So in the presentation, I showed an example of a map of a morphological impacts where we saw areas of sedimentation and areas of erosion. And that one was just for a single event, one specific storm. In the actual report, we considered a few other scenarios, not just this one specific storm event, and we looked at sort of maximum impacts, mean impacts, things like this. And there is also a scoring system I did not discuss in the presentation, but there is a metric to identify whether the impact is classified as, say, slightly negative impact or major negative impact, things like this. What is the, there's just to go back to the question, we saw both sedimentation and erosion. So it's not just limited to one. In some areas, there were potential for increased sedimentation. In some areas, there were potential for increased erosion.
Okay. Thank you for that clarification, engineer. I would just like to ask a question as well. So we have engineering students and young career scientists here in our audience. What can you advise to those who aim to pursue coastal engineering as their specialization?
Can you say again? Sorry, I didn't hear the first part.
Okay. So we have students here as well in our audience, most of which are engineering students. So what can you advise to those who also wants to pursue coastal engineering as their specialization?
Okay, so this is a hard question. My usual advice to to everyone asking this kind of question is just to sleep early, eat good breakfast, things like this. Seriously, if you want to pursue a career in coastal engineering, it's a specialized field. It's not included in most, or I think in all undergraduate programs in the Philippines. So I guess the first one is to pursue postgraduate studies. Because there are some electives offered in UP. I'm not sure if there are other coastal engineering programs or courses offered in other universities. I'm not very familiar. So probably my first advice is to pursue postgraduate studies, or maybe look for organizations that work on this field. RI is one. You can apply as a researcher, so you get exposed with coastal engineering problems. You get exposed to studies or modeling and other things that are related to this kind of work.
This is a very relevant specialization, especially in our country, and I hope we see more
Yes,
coastal
and it's
engineers in the futures.
Yeah, there are a few of us now. In the past, I don't know, past decade, coastal engineering has been gaining popularity in the Philippines. Now maybe there are, I don't know, close to a dozen or 2 dozen professionals working in this field. But definitely it's not as popular as other fields, as like structural engineering or geotechnical engineering, and we can certainly use help. It's very good that many younger students, younger engineers are gaining interest in this area of specialization.
Thank you for your advice to our young scientist engineer. Thank you as well for our participants for being active in today's Q&A session. We have received more questions, but due to limited time, we will need to close the question and answer session already. So to those who were unable to send their questions, you may send them to the UPRI Facebook page, and we will be forwarding them to Engineer Lapites. Thank you once again, Engineer, for enlightening our audience on the environmental impact assessment of Jakarta. And I hope we can apply these learnings to our projects here in the Philippines as well. So before we officially end today's episode, we would like to request everyone to open your videos for a quick photo op.
Hi, everyone. Can I ask everyone to hold their smiles? We have 3 panels. I'm going to take a screenshot of the first one. So, okay, I have the first one. Please hold your smiles for the second screenshot, second panel. Okay. And for the last panel, can I ask everyone to smile again? Okay, so I think we got everyone. I'm turning over the mic to our host now.
Thank you, April. So at this point in time, we will now move on to the end of our webinar. Once again, the webinar has been brought to you by the UP Resilience Institute and the UP NOAA Center in partnership with the UNESCO International Geoscience Program. We would also like to thank our partners from the UP Phi Delta Alpha sorority, the UP Society of Geodetic Engineering Majors, or UP GEOP, and the Association of Filipino Pharmacy Students UPLB, or APS UPLB. It was a pleasure working with you all, and very thank you to our speaker, Engineer Lapitas. The Resilience Live webinar is held every last Thursday of the month, so mark your calendars. The next session will be on the 30th of November. So stay tuned at the UPRI Facebook page for our announcement on the next speaker and featured topic. Please be reminded that the participants will be issued a certificate of attendance once they have completed the evaluation form after the webinar. You may find also the link to the form in the chat box below. To the webinar participants, we will keep the Zoom meeting to allow participants to fill up the evaluation form. Thank you once again to everyone, and see you all at the next session of the Resilience Live webinar. Once again, I am Ellen, and it has been a pleasure being your host for this afternoon.
To all participants, please be advised that we will be closing the webinar in 5 minutes. Please make sure you have filled out the evaluation form. Thank you.